Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, single elements in a sorted array. And so what this problem says is we get a sorted array, so this part is important, that has integers where every element appears exactly twice, except one element which appears once. Okay, and we want to return the single elements that appears only once. And the problem asks us to do this in O of lag n time and O of one space. So every element appears twice, except one element appears once, and we want to find that element that appears once. So for example, here, every element appears twice except 2, so we return true, 2. Now, definitely it's easy to find it in O of n time, right? We can just go through the array, and as soon as we find an element that is different than the one before it and the one after it, we return that number, right? The other way to do it is just to XOR, and what we end up with, the element we end up with is the answer, because XOR, if you XOR an element with itself, it cancels the element out, and so 1 cancels 1, 3 cancels 3, 4 cancels 4, and 8 cancels 8, and we are left with just 2, right? So that's another O of n solution to do it, but the problem asks us to do it in O of lag n time, and the array is sorted as well. Okay, and so this tells you that we should be using binary search, because binary search time complexity is O of lag n. So how do we do it? So we need to find out the binary search function that we need to use. Okay, so how can we solve it? So this is the example that we have, the first example, and I put here just the indices. With binary search, the method that I will be using, which is just finding a monotonic function that has f of x, right? That has some property where it's monotonic, which means basically values are first false and then after that they become true. Once they become true, as x value increases, they stay true, right? Or the reverse property, which is also like this. Once they become false, they keep becoming false, right? We'll stick with this one. And what we are going to need to look for is either finding the last false or the first true. That would be the answer. And what we need is to construct this function. So this way of thinking about binary search will allow you to not have any out of bound errors or any infinite loops. I will add in the description a detailed explanation of this, but essentially this is the idea. So what is the function that we can come up with? Okay, so looking at this here, one thing you notice is that if the elements, right, once the element happens, right, the positions change, right? So let's say, for example, here, let's just change this one a little bit so that it's easier to see. So before the element, right, before the element that occurs only once, what we have is that in even index, right, we have the start of a new number. And then in the odd indices, we have the second occurrence of a new number, right? So here we have the first occurrence, okay? But so this is in the first portion, like before the unique element. But after the unique elements, what happens is that you can see it from here after the unique element, which happens here at 4. Now the first occurrence is actually in the odd index, and the second occurrence is in the even index. So the order sort of flips. So now it's in odd index and here it's even index. So this is what we will use basically to just check here. So what would be our f of x? Well, our f of x, what we need for true is basically once we have the unique elements, we need this order to be true. And for all elements after that unique element, this would be how it works, right? And so how do we write this function here? So this basically means that the number at x, right, is equal to the number, because we need x to be modulo 2 is equal to 1, and the number at x is going to be equal to the number at x plus 1, right? Okay, because the number is odd, and this value will needs to be, the next value at plus 1 will needs to be equal to that value, right? Okay, now, otherwise, if x is even, right? So if it's odd, that means it's the first occurrence of the number. If x is even, that means it's the second occurrence, right? So we need to check the previous one. So we need to check nums of x is equal to nums of x plus 1, minus 1, right? Because if it's the even index, right, then this means it's the second occurrence, right? And so here, this is r, and it's one of these two, okay? I hope that made sense. So basically, what we mean here is that after the unique element, if the index is odd, that means this is the first occurrence. And so to check, we need to check that it's equal, the second occurrence is equal. If the index is even, that means we are here, we need to check the previous one, okay? Now, if both of these are true, then we are guaranteed that if one of these are true, then we are guaranteed that we are in the second part. So that means the high needs to be equal to the mid. So if this x is mid, high is equal to mid. But this is our f of x function. Okay, this is our f of x function. And basically, our f of x function just checks that we are after the unique element. Okay, and so now the question becomes, how do we move high and low, right? And so the other part of this is that we need to maintain two invariants, right? F of high needs to be true, and f of low needs to be always false. Okay. And so what this would mean here is that if this condition is true, that means we are somewhere here, right? So our mid is somewhere here, okay? And so to maintain that f of high is true, we just need to make high equal to mid. So we move our high here, we keep our low in its previous position. But if it's false, which means we are somewhere here, right? Low was here, and maybe mid was somewhere, low was here, and mid maybe is somewhere here, right? So in this case, we want to maintain that f of low is false. So we just need to move low in mid, at mid position, right? And that's pretty much it. Okay, and when do we stop? The property is that we stop here when low is at the last false position, right? And the high is on the first true position, right? And so now the question becomes, what is the answer? Well, the answer is just in our case here, we know that these are after the unique elements. So just the element before that is the unique element. So it's the last false, which basically means it's the number in position low, right? So that's the idea here. So basically what we need to use is num at low. And that's pretty much it, right? Now we have our logic, we have our function, we know how to set up our binary search. So let's just implement it. So first we need to define low and high function. So low and high. And the convention with this binary search method is to just put them outside of the boundaries so that there is no risk of our invariance being violated here. Okay, and so to do that, we'll just start with -1 and num starts at the end, after the end of the array, so that we are guaranteed this is not even in the search, the proper search, in the search space, right? And we need to exit when we are at this place, at this situation here, and this situation just means high minus low is equal or smaller than 1, but equal to 1, right? The difference is just 1, and so we will keep going while it's bigger than 1, and then we'll do our mid, and just to avoid overflow, we will use binary here, so it's going to be something like this. And now we can just apply this, but instead of using x, it's mid. So this is going to be the number, mid, this is numbers, mid plus 1, right? And then if it's even here, we are going to go to mid minus 1, right? This is basically what we said here. If it's odd, then we go check mid plus 1. If it's even, we check mid minus 1, right? And then here, if that's the case, that means we are after the unique element, and so we need to set high to be equal to mid, because high is when the function is true, and this is the function is true. Otherwise, we just set low to be equal to high. Low to be equal to mid. That's what we said here, right? And then at the end, our answer is just the number in low, because it's the last false, right? Which means basically it's just the one before the section after the unique element, right? And so that's what we return here. So if we run this, it should work. If we submit, that passes our test cases, right? So this pattern here is really important. Once you know it, you just need to find the your function and know whether you want the last false or the first true. But other than that, the setup and the values are very straightforward. Like high is equal to mid and low is equal to mid, right? I will add in the description the link to my video explaining this binary search method, but this is the idea. Now, in terms of time complexity, this is of log n, right? N being the length of the array. And in terms of space, this is of one space. We are not using any extra space, okay? So that's exactly what the problem asks us to do here. Yeah, so that's pretty much it. Please like and subscribe, and see you on the next one. Bye.